Recently, there's been a lot of interest and concern expressed about our current climate situation. We want to know what to expect in the next 100 to 200 years. However, in order to effectively analyze this climatic trend, it's important to keep in mind the big picture. This means looking at paleoclimate, the study of changes in climate throughout time. For this project, I chose to examine the delta O18 values of marine sediment cores. Delta O18 is simply the ratio of the heavy oxygen isotope O18 and the lighter oxygen isotope O16 in both the sample and the standard. I chose to analyze delta O18 values because they change directly with temperature fluctuations. High delta O18 values indicate colder climates, whereas lower delta O18 values indicate warmer climates. I first looked at marine sediment cores dating back 20 million years ago. I observed that beginning 13 million years ago, the average delta O18 value has been slowly increasing, thus suggesting a cooling of our climate. This extended period of cooling is likely due to a change in atmospheric gases, specifically the decrease of carbon dioxide. So we need to ask ourselves, what could have caused this initial decrease of carbon dioxide? Well, the most logical explanation that I found is the closing of the Isthmus of Panama. This could have drastically altered the ocean current flows, lowering the temperature of the water and ultimately allowing more of the CO2 to become soluble in it, because, as we all know, CO2 is more soluble in colder water. Next, I focused on the Pleistocene epoch. I plotted 5 delta O18 values from different marine sediment cores and found a cyclic trend of cooling periods. There appeared to be an ice age every 100,000 years. This timely reoccurrence of glaciation periods led me to believe that it could have something to do with the way the Earth orbits the Sun. Others before me have also hypothesized of this connection. In the early 1900s, a brilliant Serbian mathematician named Milankovic meticulously calculated the exact amount of sunlight each latitude of Earth's surface would receive at every orbital variation. Milankovic supposed that every 40,000 and 100,000 years, these variations would result in a glaciation period, and as I stated previously, I too reported glaciation periods every 100,000 years, thus supporting Milankovic's theory. However, our data would be even stronger if there were more marine sediment cores sampled around the equator and analyzed for their delta O18 values.